Howdy howdy! Welcome to Wikipedia Wednesday. Every week I'll be reading stuff on Wikipedia just because I'm a curious guy, and I thought it'd be fun to share what I'm reading about with you guys. So what I was reading about most recently was pinhole cameras, which is basically like a camera that works by having a little hole that the light comes in and projects that light onto a piece of film. That's how it captures the picture. But when the light comes in, it's coming in such a way that it flips the image and reverses it. Light from a scene passes through the aperture and projects an inverted image on the opposite side of the box, which is known as the camera obscura effect. And you can see that here on this little tree graphic. And I thought that was super interesting, and it kind of sent me down a rabbit hole that I want to share. And so if we come here and we start reading about the camera obscura, it talks about that effect, of course, but it also talks about the history of it, and I thought that was really cool because it goes way back. It goes all the way to like 500 BC, and it's talking about cave paintings, and we can look at the citation that they talk about here, and I'm not too sure I'm buying it, but I guess what they're saying is they have these tents that are made out of animal hide, and on the tents they found these little pinholes similar to like the aperture of the cameras. And they think that because some of the cave paintings are distorted in a similar way as the light that goes through those pinholes in the tents gets distorted on the walls of the cave, or the tent, I suppose, they think that they are kind of tracing the light, and that's how it played a role in cave paintings. But I mean, I'll leave that to you to decide if you think that it's because the light is distorting it, or if maybe they're just the first person to ever draw a horse. But moving past cave paintings, we're talking about like 500 BC here. They have sundials in China, and it's using a similar concept to cast the projection of the sun using the sundial. Moving forward further, Aristotle has a pinhole, and it's a square shape. But when light is traveling through it, it's coming out as a circle, and he doesn't understand why. And he's saying, well, maybe it's because the light rays coming in are not strong enough when they are like on the corners like that. And so it's just negligible. And so to us, it looks like a circle, but they are still there. I guess he probably just died thinking that. But it's not the case. But basically, time goes on, and they figure out, oh no, not the case. What they're seeing with the light coming through a square hole, but still being a circle, is because it's a projection of the sun, and the sun's a sphere, so it looks like a circle. But anyways, moving forward, because that's not what we're here to talk about. Camera obscura took me to visual perception. Our eyeball works in basically the same way as the pinhole camera, right? Because we have the pupil, and the light's coming in through our pupil, and our brain then converts that to like electrical signals, and that's what our vision is. So I was reading about visual perception, how's that all going down? I thought it was really cool because in a way, the light is still coming through our eyes, and it still has to be coming in and projecting an inverted image, but everything we see is right side up. So is our brain flipping everything? And that reminded me of something I've heard about many times, the upside down goggles. So Russian scientists created these goggles that uses concave mirrors, and it makes it so that everything you see is flipped again. But then after a little bit, your brain will flip it back to normal, meaning that we have the ability to do that. I thought it was super interesting that your brain can flip it back to normal. So I was like, oh my goodness, is that what's going on here? And I found this article from Scientific American that's saying, no, it's not going on. It kind of is what's going on. Because this article is saying, no, it's not that your brain receives an upside down image and then is flipping that image so that you can understand it. Your brain is receiving just the electrical signals, and it uses the senses in your ears to figure out which way up is. And then based on all of that, it kind of adjusts accordingly and gives you the correct image. Your brain is taking the time to kind of alter the information it's being given. I know that when you're in one of those sleep deprivation chambers, the whole thing is that it's making your body and your nervous system work less hard because you're floating on the water, so you're not really feeling anything. You are in like a dark room, so you're not seeing anything, and it kind of just lets your brain explore the parts that it normally wouldn't because it's kind of bored. And so I wonder if you would have any differences if you were always wearing the upside down glasses, because now your brain doesn't have to go through the step of like even adjusting it for no, because because it's always taking into consideration the rotation of your head and which way up is. Well, I guess that's the conclusion. I just thought it was an interesting little rabbit hole, finding out about the cave paintings, all just stemming from a camera. I think I'll end it there. See you next time.